Can you see the slide movements?
Yes, ma'am. It is visible.
Okay, fine. Tell other students to join the classroom. Okay. Today we'll start with the last module. Okay, so I'll show you the syllabus of that. So I'll start with the last module, that is fifth module, structures, pointers, and the preprocessor directives. I think you can see this, structures, pointers, and the preprocessor directives. Right? So this is what we are supposed to cover in the last module. Again, as per the R requirement, this is one of the needy topic, right? That is structures and the pointers and the preprocessor directives. So look at this now. Structures. So now, why do we go ahead with the structures? So till now, whatever we people have studied, okay, you already know we have studied the what we call it as the data types. So what kind of data types you have studied? One is primitive data type, another one is derived data type. So primitive data types, you already know it is integer, floating point value, right, character, double, and all those things. If you look at the derived data types, so if you go ahead with the derived data types over here, so you already know, so arrays, you have studied something like the arrays, right, and you have some other stuffs also like union and other things. Along with that, you have something called as structures. So these are all the derived data types, right? Arrays, union, structure, and enumerated data types. These are all the what we call it as derived data types, right? So you need not bother about union and the other stuff. Okay, so these are all not the part of your syllabus right now. You have studied the arrays and you have studied what we are going to study, the structures. We have already studied the arrays and some of the primitive data types. Then why do we require the structures? Is the biggest question. Why do we require structures? Is the biggest question, right? So anybody knows why do we need structures? Do you have any idea why do we need structures? Because we have studied the arrays, we have studied primitive data types. Then why do we need another data? Another derived data types like structures. Any idea, students? How do you define arrays? Any one of you? Define arrays. Hello. Hello. How do we define arrays? Any one of you? Arrays. Definition of arrays. Nobody knows
Collection
what
of
do you
the
mean?
same data type.
Very good. Okay, collection of similar data types, same data types, right? If I'm storing, okay, what we call it as the integer there. So we have this array which is capable of holding only integer values. If you want to store floating point value, I'll have an array which can store only floating point values. If I have an array of characters, it can hold only the set of characters, right? So same kind of data it is possible for us to place inside that particular memory locations or set of memory locations. Okay, that's what we call it as arrays, homogeneous data will be placed in a set of memory locations is an array. Then why do I go ahead with structures? If you look at this, we have same type of data, same kind of data. But if I feel like adding different kinds of data, okay, if I take an example, right, so human being, so now we have the names, we have the addresses, we have the roll numbers, we have the USNs, right, we have certain average marks, right. So if you look at those things, the data type associated with the human being is going to change, right. So if I take any human being there, right, so now are the student data type there. So student will have something called as roll number, which is of the type integer. So they have the marks, marks is of the type floating point. Okay, so a student will have name, name is of the type string, right. So a variety of, okay, data types. You don't have only same kind of data type here. Then if I am feeling like storing the information in a same memory location, okay, so whatever variable that I am going to define, in that particular variable, I am interested to store different kinds of data. Then how it is possible for me to store this kind of a data? So to do this kind of storage, we go ahead with what we call it as structures. We are able to store, okay, same kind of data. At the same time, we are able to store dissimilar data, okay, different kinds of data. So different kinds of data means any kind of, okay, so maybe the string, name of the, what we call it as name of the student, marks of the students, right, roll number of the students, address of the student. You go on writing the things. You are able to store that. Okay, so here if you look at the data types of these things, the data type of all these things are different here. They are not same, but still we are able to store different kinds of data in the same variable. So that variable is termed as structures. Is it okay, students? Why do we go ahead with the structures? Hello? Is it okay? Why do we require structures?
Yes, ma'am.
Right. Okay. So now, so on that basis, we'll go ahead with the definition of the structures. What are the, okay, so different, things that we people can play with these structures. So you already know about the primitive data types, right? So now we talk about the derived data types. So how do I get this derived data types? Derived data types are always derived from the primitive data types there. Okay, so derive, its name itself is suggesting these are derived with the help of primitive data types. That's why whenever we say array, array of integers, okay, it's a derived data type of a primitive data type called as integer. Array of floating point, then I'll say it's a derived data type of a primitive data type called as a floating point value. Floating or what we call it as float or a double data type, right? Okay, so here, if I say the structure is derived data type, it is derived from variety of primitive data types. Variety means you are able to store the integer, you are able to store the floating point value, you are able to store a set of characters or maybe a single character. It is up to you people. Okay, so but it is capable of holding different types of primitive data types. So that's what we call it as the derived data, sorry, the structures. Okay, so structure is derived data type. It is derived from the primitive data types. Is it okay, students? So I have an example over here. Okay, array is a derived data type, pointer is an array, derived data types, and enumeration, union, I've already mentioned. This is not there for your syllabus. This is also not part of your syllabus. We'll be studying this little after this structures. Okay, so now we are now dealing with the structure. Structure is a derived data type which is capable of holding similar or dissimilar kinds of data. Okay. So these are the things that we people can play with the structures. So what are those? First one is you have to define the data structure. we have to define the structure here, then we have to declare that particular structure variable that we have defined there, then we have to do the initialization of the structure that we people have defined. How can we are able to access the members of the structure? We call them as a members because we don't have same type of data there. We have a dissimilar data type there. That's why whatever data we are extracting at the same time, we'll be extracting only one kind of a data there, right? If you are interested to extract integer, you are able to extract only, play with only integers. If you are interested to play with floating point, okay, so mixing is not done. Okay, I cannot simultaneously play with the floating point and the integer value. Okay, so that's not true in case of the structures there. If we are, so you can store that, there is no issue. I can store the integer value, I can store the floating point value in the same structure that I have defined here. But whenever you are extracting, you are able to extract the contents of that, or you are interested to place something, you are supposed to place that particular data into that particular memory location associated with that particular primitive data type itself. Okay, so now meaning of that is, if you are interested to put the data inside the integer, so that integer is going to become a member of that particular structure where you people can play with the integer. So this floating point is going to again become a member of this particular structure where you people are able to access the contents of that particular data, or you can able to place the data. So similarly string and other stuffs, right? So those are termed as the members. Okay, this is very important stuff that you need to remember. Whenever you play with the structures, please remember the datas of this particular structures are termed as the members, and you are able to access. Access means either you can dump or you can read the members of this particular structure there. Then next one, so we'll just show how you people are able to go ahead with the dumping of the data into the memory for this particular structure, because structure is a single variable which can able to store dissimilar or similar kind of data there. Okay, because you already studied the arrays. If I write here A, so in A of 0, I am able to store one data there. So A of 1, A of 2, this is how, okay, data, you people can place the data inside the memory. Okay, so similar to this, we are able to show the memory structure for the, or memory representation for the structures also, that we are going to study under the heading called as memory representation of the structure. So this is very important fact that I am dealing. So first one is definition of a structure is very important. Then declaration of a structure variable, that is also very important, because if you don't declare it, you are unable to use the structure there. Okay, just definition is not going to help me. Okay, definition of a structure is not going to help me. So definition just tells the, or inform the compiler that you are going to play with the structures. Okay, or the programmer is going to play with the structures. But if you go ahead with the declaration of the structure variable, then you people are really, okay, can play with the those structure variables. Okay, this is what is the meaning of that. If you don't declare, if you just define it, it's of no use, right? Okay, so soon after definition, we'll go ahead with the declaration of the structure. Then after declaration, so you have to dump something into that particular structure that you people have defined there. That's what we call it as initialization of a structure there. How you people have done with the arrays, in the similar fashion we people are playing with the structure. There you went for only similar kind of data. Here you people are going ahead with the dissimilar kind of a data here. Then you people can read the contents of the members of the structures. You can store something into the members of that particular structure there. Then, so we'll finally talk about the memory representation of the structure. Okay, so let's begin with the first stuff, that is definition of a structure. You already know about this. A structure is a collection of one or more similar, or please remember this may be a similar or dissimilar data types, okay, which are grouped together under a same name, because it's the same one variable, it's one one variable. How you people have played array of, if I write here int of a of 10, the meaning of this is it's one simple variable which is capable of integers, right? So similar to this, also one variable which is capable of storing either similar kind of data or dissimilar kind of data, right? So it may be able to store the integer, floating point value, again, I mean, maybe the set of characters or a single character, something like that. Okay, but it's a single variable which is capable of storing dissimilar data types there, right? So this is the definition of a structure. So any doubt in this, students? Any doubts?
No, ma'am.
Okay. So structure is derived data types containing multiple variables, okay, of homogeneous or that is similar or heterogeneous data types, right? That is dissimilar data types. Okay, it is capable of storing same kind of data as well as okay dissimilar or heterogeneous kind of data also. So that is the importance of a structure. Structure plays very important role. Okay, so with this background only, you people are going to learn the upcoming semester subject called as data structure. So this base is very much required for you all. Okay, so the first step towards the data structure is you need to know the definition of a structure. So structure is a derived data types which is capable of holding either similar kind of data types or dissimilar kind of data types. Okay, so what is that syntax for defining the structure now, right? So let's look into this. The keyword that we people are using to define our structure is struct. I'll repeat, the keyword that we people are used to define the structure is struct. Okay, so struct is a keyword. Then this struct is going to be followed by an identifier. So whatever name you are interested to give for that, so that we people are using in front of this particular struct. Okay, so that identifier is usually termed as a structure tag, right? Tag associated with a particular structure. Look into the syntax. Okay, so syntax is now struct, it's a keyword. It's a keyword. And tag name, right, are the identifier. So we are going to give we are going to define a structure under a heading called as or identifier called as the struct underscore tag. So inside this, you already know it is capable of holding same or a dissimilar kind of a data types. So we have variable 1, which is of the type 1 data type. Variable 2, which is of the data type, maybe the same data type or a different data types. You can have n number of data types followed by, okay, the variable name there. So if I write example here, so int v1, float, okay, v2, then I have char v3. Okay, so you have different kinds of data under a heading called as the okay this tag. So these are all the members of this particular structure. Is it okay, students? This is very important fact I am dealing with. Questions. So struct is a keyword. So struct tag is an identifier, right? So this particular structure is having variety of data types there. It is up to you people how many data types you wanted to have, how many different kinds of data you are interested to place into that particular structure, whether you want to have only one data, whether you want to have multiple different kinds of data. So you just go on writing the variable names along with steps. So that helps you to store a different, all kind of data under heading as tag. All the members particular structure. So please this whenever you define like this, so this must be the okay end with the semicolon. So any doubt in the syntax of the structure, students? This is very important what I am conveying you, because your third semester data structure, the first model begins with this structure only. You can look at the name itself, data structures. Okay, it has to begin with structure itself. Any doubt in this? Any doubts? Example. So let's take the example. Struct tag name. It's an identifier. Any name you can give. I've given it as student. So what this student consists of. So I wanted to have the information related to the student. Okay, that's why I have taken this. So this is character name of 20. So this is nothing but the string. Okay, it's an array of characters. Array of characters. So it is capable of holding the name of the student. Int roll number. Okay, so this is this particular variable is capable of holding the student roll number. So average marks. This is capable of holding. It's a floating point data, which is variable, which is capable of holding marks the particular student here. Is it okay? So now these are termed as the members. Name of 20, roll number, average marks. These are termed as the members. Members of what? Members of this particular structure. The name of the structure is student, or the identifier name is student. Is it okay? This is just a definition. Definition will not help me to do anything. You cannot play with this until if you don't declare it. Okay? So this is just, you are informing it to the compiler that I am going to use a structure variable inside my program. Okay, I am going to declare that. So before I declare, I need to define the structure there. So that's what we people have done here. Clear? So this must be written, always written before the main function. So these structures must be defined before the main. Clear, students? This is the definition of a structure. So this definition must be written before the int. So any queries, please feel free to ask the questions. Don't hesitate. Any queries? Any queries, students?
No, ma'am.
Okay, let's go ahead with the declaring structure variable. Now I have already defined the structure. Now I wanted to use those structure inside my program. Okay, then how can I do that? Okay, for that you need to declare that, right? Without declaration, you people cannot use the members of the structure, right? To use the members of the structure, you need to declare it. And how do I declare that? So let's look into that. Syntax for declaring the structure variable is shown here. So structure, it's again keyword. How you people have done something like int, right? So similar to that, you have to use a struct there, followed by whatever tag name you people have given. Okay, in the previous example, we have given the struct name, struct tag as student here. So you people can write it as student here, right? So I've created the variable, okay, of the type student, which is of the type structure here, which is having these three members under that particular tag name. Okay, so now, so you have created three variables, v1, v2 and v3, sorry, not only three, so up to vn variables. You have created these many variables. So these are all of the type the student struct, or the struct tag. I'll repeat my statement. These are all the variables which are of the type this struct tag. Okay, so if you look at this example, struct student S1, S2, S3. So S1, S2 and S3 are of the type student. So student is of the type structure. So which is having three members as a part of it. Okay, student is having three members as name of the student, roll number of the student, marks of the students. Okay, so now whatever members you people have written for this tag is valid for these variables. If you are interested to play with this particular student structure here, now you need to play with S1 these variables, because until if you don't declare it, okay, so definition will not help me to play with the structures, as I have already mentioned. You have to declare it. Okay, you have already declared it. Okay, so this is how you people have declared. Now you people can play with the structures with the name called as variable name called as S1, S2 and S3. Is it okay, students? Is it okay?
Yes, ma'am.
Say, right. Okay, so look at the another example that I have quoted. So this is the struct student. Okay, so name of the student, okay, and roll number of the student, and the floating point as an average marks there. So this is the structure. Okay, that this is nothing but the definition. So these are all the members of the structure called as the student tag. Sorry, student, right? Okay, then I have to declare it. So this should come before main. Okay, so now I'm going to use, okay, this particular structure inside my program. So that's why I need to declare it. How do I declare? Okay, the declaration is something like struct, which is a keyword followed by the whichever structure tag I'm having that I've defined before the int there, int main there. So that I have to write here. Okay, this is a student that I have defined here. The same thing I am writing here, followed by the variable name list. So CSC variable name list, ISC variable name list, comma, you can write S1, comma, S2, comma, S3, comma, up to, okay, SN. How many variables you want, you people can define there. So these are all the variables of the type structure which are capable of holding the information regarding the student. What are the information? These are the members, right? So you can hold the student name, you can hold the student's marks there, you can hold the student roll number there. So these are all the information that I can dump inside the any one of these things. Okay, so it is true for CSC, it is true for ISC, it is true for S1, it is true for S2, it is true for S3 till, okay, it is true for SM. Is it okay, students? So this is how you are able to declare. Then where do I declare this? Okay, this is very important for me. So soon after int main, whenever you write, you have something called as a declaration section, right? Do you declare the variables? Do you declare the variable soon after the open brace of the int main there, students? Yes, students. Where do you declare the variables? Hello? Where do you declare the variables? Where do you declare the variables? Say something. Where do you declare the variables? Hello? Hello? Where do you declare the variables? Any one of you students? Please interact with me. Hello? 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 Interact with me, students. Where do you declare the variables? Are you declaring the variables anywhere you want? Hello? Okay. So these are the variables that usually we declare soon after the opening brace of the int main, right? So here only you people are able to declare this particular structures also, right? So now I am interested to declare the structure here. So these structures can be declared soon after the opening brace of the int main there. Okay, and whatever variables that I am going to write for these structures. So these are helping me to, or these are the variables I am going to use for those structures. Right, so whichever structure that I have defined. Okay, so now I am able to use all these members under the variable name called as whatever variable name you have written for it, which is coming under in the, coming in the declaration section there. So this is how you people are able to declare the variables, right, or declare the structures. So once we know about this, then we'll go ahead with the structure initialization. Next bit is, how can I initialize the structure? How you people have done with the initialization of the arrays. In the similar fashion, we are able to do the structure initialization. Okay. Again, there are two types of initialization that you people can play with. One is initialization during the, okay, what we call it as the compile time initialization or a runtime initialization. In this case, I am showing you the compile time initialization. How we people are able to do that? Okay, so now you already know that these are the, okay, the structure declaration, right? So struct tag followed by the variable name there. So in front of this, if you people are able to write equal to sign and write, open the open brace and go on writing the name or the values over here and close this brace. So these are the values that we people are able to place inside the members of the particular structure that we people have defined for this. So look at the example. You already know student. Student is having how many different kinds of stuff? Okay, it is having the name of the student. Okay, name of the student, roll number of the student, and average marks. Right? These are the three members that I can initialize for this particular variable under the tag name called as the student here. Right? Look into the same thing now. Struct student CSE. This is one particular variable is of the type student, which is of the type structure, which is having three independent members. Right? Okay, so now first one is the name of the student followed by the roll number of the student followed by the what we call it as the average marks of the student here. So look at this. This is how you people are able to initialize the structure. So if you look at this, these are all different kinds of data types. This is the set of characters, right? So string we call it as, this is an integer data type, this is a floating point data type. Right? So CSE is a variable which is of the type. If you don't do this, then I cannot directly use struct student is equal to this. That is not correct. You have to first go ahead with the declaration. In the declaration part, whichever variable you have used, in that particular variable, you people can dump the structure variable there. Sorry, structure data there. Okay, this is very important for us. Okay, now look into the complete stuff along with the declaration, definition, and the initialization. So first one is structure definition. Okay, so now look into the structure employee. Employee is a tag name, structure tag there. So what it consists of? It consists of what we call it as the character, name of the employee, salary of the employee, ID of the employee. So these are all, okay, having the same data type, this is having a different data type. No issues, right? Because it's a structure. Structure is capable of holding dissimilar data type there. So once we have done with this, so I'll go ahead with the main here, right? So soon after main, we have a declaration. In the declaration section, I'll be using so structure employee, right? So emp1 comma emp2. The meaning of this is I've created two structure variable emp1 and emp2. So these are of the type, okay, what we call it as employee. Employee is of the type struct. So what is the struct definition for this employee? So this is a struct definition for the employee. Is it okay? Is it okay, students?
Yes, ma'am.
Okay, so now if you go ahead with the initialization here, right? So struct employee, okay, so now it is emp1. So I have initialized the thing now. So now if you have already done here, right, so no need of writing this directly. People can write EMP1 because EMP1 is of the type already employee. I have already declared it, right? So this is declaration along with the initialization or initialization during the declaration itself, right? So if you are not interested to do like that, first you declare it, then you initialize it, right? Both are valid only. So employee, it is capable of holding the name, salary and the ID. Okay, so you have one more stuff called as, okay, so one more employee, that is employee 2, okay, which is having a name of the employee and the salary and the what we call it as the ID of the employee. Right, this is how you people are able to play with the structure definition, structure declaration and the initialization. Initialization can be done during the compile time, that is during the declaration only you people can do that, or soon after declaration you people can also initialize the structure there. It is up to you people. Right, so this is what we call it as initialization, that is compile time initialization. Then how can I access the members of the structure? Okay, so if you look at the, accessing of the members, right? How can I read or how can I dump the data into the members of that particular structure? So now to access the members, if you look at this, these are the members. So name is one member, salary is another member, ID is another member. Then how can I access these things? Right? To access these things, we go ahead with what we call it as the dot operator. This is very important for us. The dot operator is helping me to access the individual members of the structure. Okay. So this is the only best feature of this particular structure that helps me to access only one member of the structure or two members of the structure or all the members of the structure. Okay, so people can play with single member, you people can play with double members, you people can play with all the members of that particular structure. If there are three members, you people can play with all three members. You people are interested to play with only the name of that particular structure, you people can only play with the member, that name member of the particular structure there. Okay, it doesn't mean that you have to, it is having three members here, you need to play with always three members. No, it's not necessary. You people can play with any members. How many members you wanted to play with. Okay, you people can play with either one member of that, two members of that, or all the members, right? And there is no necessity that you have to follow an order for it. No, it's not necessary. If you want to read the salary first, you can read the salary first. You want to read the ID first, you can read the ID first. Okay, if you want to read the name first, you can read the name first. Okay, so you people can access the members how you people are interested in. So there is no need to follow the particular order for this. Is it okay? Is it okay, students?
Yes, ma'am.
Right. Now look at the example. So I have already declared along with the initialization. Okay, we have done the initialization along with the declaration here. So struct employee E1 is equal to, so this is the initialization that I have done. Now I am interested to access the members. I wanted to know what is the name of the particular employee. Then how do I access? You know that, right? So it's a dot operator that helps me to access the individual members, right? So what is the name of the particular variable that I have used for this employee? It's E1, right? E1 is the variable name. So this is meant for this particular employee. Please remember, without this I cannot do anything. I need to declare it. I have declared it, right? So this is E1. So I wanted to access the members. So what are the three members? One is name, salary and the ID. So I'll write E1, okay, followed by the name. So this is the name, which is nothing but the member of this. Okay, then I have E1 dot, if I write directly ID there, so this is an ID there. So E1 dot name is going to give me Okay, either Rama or Rama. It is left to you people. So if I write E1 dot ID here, so this is the ID of that particular E1 structure, right? It's going to give me 2001. Here it is going to give me Rama or Rama. Is it okay? It's a dot operator that helps me to pick the individual members of a structure that I have already defined in the definition of the structure there. Is it okay, students? Hello?
Yes, ma'am.
Right. Okay. So this is very important because again and again I am mentioning you all, your next semester's data structure begins with the structure. There you should be able to access these members, right? So either you people will be playing with the dot operator or you have one more concept called as arrow. Okay. If it is there, I'll be dealing with that also. If it is not there, so I'll be studying that in the data structure itself. Okay. So you have okay, you can access that particular member using either dot operator or using an arrow. But want to use that particular arrow, okay, so we'll be looking into that a little later. But this is one of the method that I've already mentioned you people. How can you access the members of a structure? Next, look at this. So displaying the various members of a structure. How can I display the members of the various members of the structure? Okay, for that, okay, using you already know. So you have to declare those many variables, right? So after declaring those things, you go on dumping the or initializing that particular variable there, right? So once you initialize that, you people can either display or you people can, if you are interested, you people can either read the data. So then let's look into that. I'm interested to display the members. So which are the members? If you take the previous example for the student or the employee, you have the name of the student, you have the roll number of the student, you have what we call it as the average marks of the student. Okay, those are the three members and you know that how can you access the members. Okay, variable name, dot operator followed by the member name, right? So if you look at this, E1 is the variable name followed by the member of that particular variable, and this is a dot operator that is helping me to pick the member of that, right? So E1 dot name, so it's going to print the name of the employee. So E1 dot salary, it is helping me to print the salary of the particular employee. So E1 dot ID, it is helping me to print the employee ID of the student there. So now if you look at this previous example, it's going to print Rama 10 or Rama 10950 and 2001 on the screen. Is it okay, students? Say something.
Yes, ma'am.
Right. Okay. So reading the values for the various members. Okay. So now how can I read these things? Right. Now I have displayed. Now I am interested to read. How can I do that? I've done the initialization, but now I wanted to do it. During the runtime. Okay. Whenever I am executing the program, so that time I am interested to dump the members of that particular variable. That is structure variable. Then how can I do that? Okay, let's look into that. You are interested to read the name member of the E1. Okay, employee E1. Okay, you wanted to read the salary of the employee E1. You wanted to read the identification number or the ID number of the employee E1. Okay, then how can I do that? You already know. How can you read the data during the runtime? Okay, so if you are interested to read the string there, so getS. getS means it is helping you to read the string there. So read, that is getS. So E1 dot name. So E1 is already declared here. You already know about this. E1 is declared, right? So it is of the type employee, employee is of the type structure, which is having these three members here. Right? So E1 dot name. So you are able to read the name of the employee. You read any name for it. Next one is scanf. So scanf is reading something. What you are interested to read? You are interested to read the salary of the employee, right? So how do I access that particular member? E1 dot salary, right? So as it is, I am reading the floating point value. I am reading a floating point value. Is it okay? Or you people have done with the, okay, reading the array in the similar fashion I am trying to read. But here you have a dissimilar data. There you had a same kind of data. Is it okay, students?
Yes, ma'am.
Okay. So next one is you are having what we call it as the identification number, ID, right? Okay. So now again, to read an ID here, so I have something called as, okay, something called as E1. Member of this is ID here. So to find it as a member here, so I am using a dot operator. So E1 dot ID. Okay, so I am going to read it inside the array using a scanf statement. It's a runtime initialization, right? So scanf, okay, that's why I have used the ampersand there. Okay, you might have, you already know for this string I never use any ampersand, right? So I have not used any ampersand for this. I hope I'm making it clear. So either you can use getSR, you can use scanf there. So scanf percentage yes, you people can write, then followed by E1 dot name. E1 dot name. Okay. So I'll not be writing ampersand before this because it's a set of the characters. Okay, it's a string. Is it okay, students? We'll go ahead with memory representation of the structure. Okay, now look at the memory representation. So what is memory representation? So whenever we go ahead with the structure, structure is declared, right? Okay, sum of a memory of, okay, heterogeneous kind of data, and it is allocated again continuously. Okay, please remember this is you are given with the contiguous memory location for that. Okay, so now look at this. So whenever I declare, it's going to, okay, it is going to give you the or allocate you the memories in a contiguous manner, right? Whether you are declaring or whether you are using the different data types also, it's there is no problem for it, but it is going to give you the contiguous memory location. So if I take an example of the student there and I have declared it as ES1, okay, it is created a memory, it is created a memory for the structure in the name of ES1 there, which is capable of storing, okay, the different kinds of the members or the different kinds of data there. What kind of data? First one is name, next one is the roll number, next one is the, what we call it as average marks there. Okay, so this is how it is going to allocate the memory. This is very important for us. For every member it is going to allocate, but it is going to allocate the memory in a contiguous manner. Okay, so some memory will be allocated, some memory will be allocated here, and some other memory will be allocated here, and some other memory will be allocated here. This is not true with the structure here. Contiguous memories are memory locations are allocated for the structure. This you have to remember. This is very important for us because students will say it is haphazardly, the memories are allocated. No. Okay, memories are allocated, okay, to the individual members of that particular structure variable contiguously. But how it is done? So how you people have defined inside the structure, in the similar fashion, the memory is going to be allocated. If name has come first, so it's going to reserve the memories for the name first. Then if you have taken roll number second, then soon after the name, okay, it's going to reserve the memory location for the roll number. So soon after that, if you have declared something called as the average marks there, and it is going to reserve the memory location for the average marks soon after the roll number there. Okay, so look at the stuff. But before that, one more stuff I wanted to convey here, the sum of memories. Okay, so sum of memory means, okay, it is the addition of the memory locations required for all the members. Okay, so if I write here, if you look at the example here, okay, so now if you look at this, so character name. So how many memory locations are reserved for this, students? Name of 10. How many memory locations? Any one of you? How many memory locations are reserved for name? Hello? How many memory locations are reserved for this particular name memory? Name variable or name member? Any one of you, please? How many memories? Is it 10 memories, 20 memories, 30 memories? How many memory locations are reserved for this?
10.
10. Why 10? Why not 20? Yes, you are absolutely correct. Why only 10? Why not 20?
Because we declared as 10 character name 10.
Character name 10. Okay, why it is reserving only? Okay, so let me write it. Instead of this character, if I write it as 10, how many memory locations are reserved for this? Name of 20. Let me write it, sorry, name of 10. Int name 10. How many memory locations are reserved for this? Is it 10 memory locations or more than that? Okay, I'll take another example. Character C. How many memory locations are reserved for this? For C,
1.
1. Okay, so for int A, how many memory locations are reserved?
4. 2.
Is it 4 or 2? Four or 2? How many memory locations are reserved for int A? 2 or 4?
2, ma'am.
2. Correct, no? If it is float, how many memory locations? If it is float, how many memory locations? Make it fast. If it is float, how many memory locations? 1, 2, 4, 8, how many? Hello? How many? How many memory locations? Little louder. How many memory locations? If it is float, how many memory locations?
4, ma'am.
4. Correct now? Is it okay?
Yes, ma'am.
Right. Okay. So now if I have said int name 10, how many memory locations are reserved?
20, ma'am.
Correct? Is it okay? Is it okay?
Yes, ma'am. Yes, ma'am.
Right? Okay. Instead of int, if it is character, how many memory locations?
10.
Yeah. Clear?
Yes, ma'am. Yes, ma'am.
Clear? Okay. So now it's going to reserve 0 to 9 locations for the name. Okay. For name, it is going to leave 10 spaces. So after that, how many locations for the salary? How many locations
4.
for the salary? 4. Right. So 10, 11, 12, 13. So till 13, you have all facility to store salary. Then how many locations are stored for the, left for the ID then?
2, ma'am.
2, right? So this is 14 and
2.
15. Totally how many locations are reserved for this particular employee? How many memory locations
15.
total for here?
15, ma'am.
Is
15.
it okay? Clear?
Yes, ma'am. Yes, ma'am.
Is it 15? Location 16 memory location. 0 to 15. How many memory locations? 15 or 16?
16, ma'am.
Correct, no? So 16 memory locations are allocated
Ma'am, why is it
for the
breaking, ma'am?
E1 memory. You're unable to hear me?
Your
Are you
voice
able
is
to hear me or
breaking.
no?
Why is this breaking, ma'am?
No, can you hear me now? Can you hear me or no?
Yes, ma'am. Yes, ma'am.
Okay, fine. Right. Okay. So totally 16 memory locations are reserved for this particular employee E1. Is it okay? Clear
Yes, ma'am.
now?
Yes, ma'am.
Right. Okay. Look at the same thing. Now look at this. Totally 16 bytes are reserved. Okay. So 16 bytes are reserved. 10 bytes for the name of the student. Okay. Or maybe name of the employee. 4 bytes for the salary and 2 bytes for the ID. Right, totally 16 memory locations, right? So that's what we have written here. So totally starting from 0, right? Okay, right. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And then 10, 11, 12, 13, 14, and 15. So this is going to store, okay, RAMA, Rama, followed by the null characters there because it's a string. So it is going to occupy only this. Okay, so because nothing is there, okay, I have only this much of data, but nothing is there means it's going to leave it as either blank or it may, fill it with the backslash 0 there. Then followed by what we call it as next member is salary there. So you can enter salary using 4 memory location there. You can dump your salary in these 4 memory locations. So identification number can be stored inside the 2 memory locations using 2 memory locations. Is it okay? Is it okay?
Yes, ma'am.
Right, so this is the memory mapping. This is very important fact, or you need to know this because I already mentioned. Okay, so in the upcoming semester directly you'll talk about related to the stack queues there. Okay, so there you need to actually play with these memories, right? Okay, so if you know this memory map, how it can be adopted for the structures there, then you have, okay, done with the at least beginning of your data structure there, right? Okay, so now let's look into the next bit of it. So a simple example that I've taken here, right? So that is programming example. So let's look into that. to read and write the structure called car, right, with the members like name, model, and a price. Okay, so I have the name of the structure as car. I've defined it. What it consists of? How many members it has having? 3 members. What are those?
Name, model, and price.
Right? Name, model, and the price there. So price is floating point value. Can I take it as floating point value? Or can I take it as
Yes,
integer?
ma'am.
What shall I take for price?
Floating point.
Correct? Because it should be something like, something like 10.5 lakhs, something like that, no? It is in terms of floating point values. You'll be writing, okay, so 10 paisa, 50 paisa, 100 paisa, 99 paisa, something like that. Right? Because 100 paisa is 1 rupee itself. Right? Okay, so next, model. Model should be always an integer. Okay, so you can see the things. You can look into the model of the stuff there. So model will be a longest number, or it may be a combination of what we call it as character and the integers there. Okay, so you can take it as either string, but in this case, we'll take it as a integer itself. We'll give a number for that. Right? It's a model. Okay, I'll be saying it's a 2009 model, 2021 model, 2011 model. You'll be saying something like that, no? Yes or no?
Yes, ma'am.
See, right. Okay, so name of the car. Okay, you already know. Maruti, Suzuki, right? Something like that. Wagoner. Hmm? Right? So those are the names of the cars. Right? These are the different members of the cars. So other than this, if you want to define some other stuff also, there is no issue. Here they have given some samples that we have taken there. Along with this, you wanted to write some other stuff also. That also can be added as a part of the this particular structure. Okay, there is no restrictions on the members that we are going to define there. Don't think you have to define only 3 members, 4 members. So it is left to you people. You can have n members. I've already started with. I have already shown that in the. In the previous slides. Okay, V1, V2, V3 up to Vn. Okay, so you can have n number of members as a structure. Under the definition of a structure there. Right. Then I said, okay, so this is the definition of a structure. Once we define this, so this is purely meant for the compiler. You are telling that I am going to use this particular structure inside my program. Right? Okay, so it is said, okay, compiler is saying, okay. Then it's your duty to declare that. So declaration is going to help you to create the memory location because you have presentation. Declare it. If you don't declare it, no memory locations are allocated. Definition will not allocate the memories. Please remember, this is very important. Maximum times in the interviews they'll ask, okay, I've defined the structure. Okay, his compiler has allocated the memory to the structure, they'll ask you. If I've defined the structure, is this definition of a structure has allocated the memory for this particular structure? Hello? Hello, students. Hello?
Yes, ma'am.
So here, this is a structure definition, right? Is this structure definition has allocated the memory for this particular structure? Is definition is helping the compiler to allocate the memory? Yes or no? If it is no, then when it is going to allocate the memories? Say something. Is this definition is going to allocate the memory? Make it fast. I have to close today's session. Please. Is this definition is going to create the allocate the memories? Say something. Many times I have mentioned. Okay. Is this particular definition is going to create or allocate the memories?
We need to declare it.
Right. Okay. If you don't declare it, no memory is allocated for this. It is just the information to the compiler. Okay, definition of this particular structure is just we are informing I am going to use the structure inside my program. Once you declare it, okay, during the declaration section, I already mentioned, soon after the main, I am going to declare it. How do I declare? The struct, the keyword followed by the tag name of the structure definition, right, followed by the variable name. Right, so I have taken only one variable. You can have multiple variables here, something like struct car. You can have C1, C2, and so on up to CN. It is up to you people how many variables you want. Those many variables of the type car you people can create. Okay, it is up to you people. But I have created only one variable called as C1, which is of the type car, which is of the type structure here. And this is capable of holding how much of data? How much of data can be dumped inside this particular C1 car? I mean, C1 variable.
16 bytes.
Correct? Is it okay? So this is also, I mean, 16 byte is true for this also, because whatever stuff we have written for the previous case is true for this also. Okay, so instead of this, if I write this as double, price double. So how many memory location? For double, how many memory location?
8, ma'am.
8.
8. Correct? No? For model int. For int.
2.
4, ma'am.
2. Correct? For character, 10, name 10.
10.
10. So total how many memory locations?
20.
20.
20. Is it okay? Is it okay?
Yes.
So 20 memory locations are reserved for the C1 memory. I mean C1 variable. Okay, so these 20 memory locations are created once you declare it. This definition of the structure won't create these 20 memory locations or reserve these 20 memory locations. Okay, in this case it's not 20, again 16 itself, because I've taken it as the float here. Right, so float is only 4 memory locations. Okay, float is 4 memory locations. This is 2 memory location. This is 20. So total 16 bytes. Right? Okay. So now 16 bytes are not reserved by the definition. But once you declare it, right, for this C1 memory, so 16 memory locations are created, are reserved. Is it okay? So 16 memory locations are created for what? 16 memory, very good. Okay, so 16 memory locations are reserved for this C1. Is it okay? If I write one more C2 here, for C2, how many locations are created, are reserved?
16.
Very good. If I create one more C3, how many memory locations are reserved for this?
Same 16.
Same 16. Is it
16.
okay? Right. Okay, this is how the structure is going to show its capacity. Right? Okay. Next, I am interested to read the data for this. I am accessing the data. How can I access the individual members of the variable structure C1?
Dot
How
operator.
do I dot operator? Very good. Now C1 dot name. So I am going to read the name of the car. So I'm asking you to enter the model. Okay. So I'm reading the model. So C1 dot model. It's okay. Model there. It is integer. That's why I've written it as percentage %d. Then I have a price of floating point. That's why I've written it as scanf percentage f Okay, how you people have done for reading the data in the similar fashion, only you have to access the members of that particular structure. Only that is a difference. Okay, other than that, it is same as what you people have played with the other variables. Okay, so then I am printing the same thing here. Okay, so name, how do I print? Again, using the dot operator. So percentage yes, C1 dot name, percentage D, C1 dot model, percentage F, C1 dot price. So if you look at this, I'm entering these things. So this is the name of the particular car, this is the model of the car, and this is the price of the car here. And it is printing the same thing. Is it okay? Why it is printing so many digits after a decimal point? Why it is printing so many digits after a decimal point? Make it fast. You already know all those things. Why not only 9.58 it is not printing? Why it is printing for 9.580000 there? Simple
Because
question
we
I've
haven't
asked.
mentioned
Very good. What you are not mentioned?
the 0.2
Very
percentage.
good. Very good. Right? Okay. That's why it's not printing that. Is it okay?
Yes, ma'am.
All right. So this is the introduction part of the structures. The other part will be dealing in the next class. So have any queries, you people can ask me. Otherwise, we'll close today's session. Please feel free to ask the questions if you have any. Don't hesitate.